Hi, hello everyone. In the last class, we discussed about valuable material, different material properties, that is malleability, ductility, and brittle nature, fatigue. So we discussed about all these things. Now we will discuss about the important concept in the strength of materials. In understanding strength of materials, the most important topic we need to learn is stress strain curve diagram. Here, what we are seeing is it is a stress strain curve diagram for Fu 250 mild steel bar. So how this chart was developed, this stress strain curve how developed. So in the x-axis we will take strain, in the y-axis we will consider stress. So as the stress increases on the specimen, in the same way the strain is also increased. So how we will test it? In the laboratory we will use UTM, universal testing machine. So universal testing machine is a machine which is used to test the different materials. In this we will select a specimen. So we will select a specimen of mild steel and we will place it in between the grips of UTM and we will apply the load. As we applying the load, the strain will also increase. We will measure the strain of the specimen by using extensiometer. So extensiometer will show the values how the deformation was taken place and how much it was elongated. So for which distance we need to fix these grips. So for this we will use a formula called gauge length. So for different materials there are different gauge lengths based on the size of the specimen we taken. So pi d square by 4 is the area. Here A0 is the specimen size. So as the diameter increases, the specimen gauge length will also increase. The gauge length is the length, nothing but for what length we need to measure the extension, that is elongation. Okay, as the load increases, the extension also increases. As the extension increases, the delta L increases and the strain is also increased. Okay, as the strain increases with the load, so we will plot different values. For a 10 Newton per mm square strain, we will get, for suppose 0.1 strain. Okay, so here for strain there is no units, right? So for 20 we will get another point at 0.2. so there is, in this way, as the stress increases with the time, the strain will also increase for certain limit. After that we will get a lower yield point. Okay, so the strain will be linear, stress strain will be linear up to limit state of proportionality. So here A is limit state of proportionality. After that it will be slightly elastic in nature. As the specimen load increases, the specimen will remain same. So up to the elastic limit there is no change in the specimen. As the load removed at the elastic limit, the specimen will come back to the same position, at the original position, that is in the beginning how the specimen will be, the specimen will become the same. There will be, we cannot see any extension, but after the elastic limit there will be a change at a point C. This point is known as upper yield point. There will be a sudden drop of stress here. Okay, so the specimen will undergo the change in the physical appearance. Okay, so the rearrangements of particles will take place at this point at plastic limit. Okay, so here the whole structure of the whole molecule structure of the specimen will be changed. Okay, so here after this point we will go to another point called ultimate point. So this is indicated by G, and next we will see a cup and cone failure at a point called breaking point is F. Okay, so here the specimen will take proportional stress to strain up to limit state of proportionality. The strain which is correspond to limit state of proportionality is nothing but it's our Young's modulus. Okay, So by drawing the stress strain curve diagram for different materials, we will know how that material is behaving. For suppose for Fe500, the stress strain curve looks like this. It means it will fail suddenly, right? So in this way, if you draw for brittle material, for suppose glass will not also, glass also do not have any specific zones of failure. These are all absent because the failure is sudden, but in the mild steel it will undergo lot of deformation, so after that it will fail. So that's why we will call Fe250 as ductile material, but Fe500 is brittle material because there is no such zones, there is no such yielding zones in this Fe500 or Fe430 materials. So that's why these are all brittle materials. So by watching the graph of stress strain curve, we can simply say the nature of the material and how it will react to different loads, different stresses. So understanding stress strain curve diagram is very much important in strength of materials and in the whole civil engineering itself. Okay, so the gauge length is the very much important factor we need to consider, and the lower yield point, whatever we are seeing here, Fe250 or Fe400, Fe500 is corresponded to lower yield point. We will consider lower yield point, that is D, as our lower yield point. Why we will consider lower yield point as our yield stress? Because in the lower yield point, as we compare many materials, in the lower yield point there is no change if the specimen size changed, if the specimen length changed, but the lower yield point remains the same. So that's why we will consider which is constant, that will be considered as our lower yield point. So now here the D option, the point D is lower yield point, is considered as our yielding stress. So Fe250 is nothing but the lower yield point of the steel, of mild steel. So that's why 250 Newton per mm square is the lower yield point. That is our yielding stress. So in this way, stress strain curve will help us to understand different materials. For time, as in the last class we discussed about malleable material. So malleable material is strong in compression and after that tension and after that shear. So in this way it will take a lot of compression, but in ductile material, for suppose mild steel, in mild steel tension will be the dominant force. Any ductile material will take more tension. So here we are saying that Fe250 is a mild steel is a ductile material because it will have a lot of elastic region. So lot of elastic region up to the failure. So that's why ductile material takes a lot of tension, because it can take a lot of load before the failure. It will cross all these zones. So which type of material will take more stress, a more elastic zone, that is all this stress area, lot of stress strain area is ductile, it is considered as ductile material. But whereas in brittle material there will be a sudden failure because they don't have much more area undercovered below the yield zone, so before the failure zone. So that's why we will consider it as brittle material. So by knowing the stress strain curve, we will understand the material property easily at different loads and different strains. So that's why we need to learn about stress strain curve diagram. Okay, thank you very much for watching.